So let's start with a history lesson. We'll start with a history lesson. And history lesson goes like this. What are the origins of chemistry? The ancient Egyptian hieroglyphs refer to chemia, which was a chemical process for embalming the dead. You know, the Egyptians were very fixated on the afterlife. And the chemists were revered in that society, not like here. They were revered in that society because they knew how to prepare the body for the afterlife. Embalming is a chemical process. A few years ago, I was in London. I toured the British Museum and came upon this. This is 18 inches tall. It's the mummified cat. It's a fantastic example of mummification. It's beautiful. Most people go zooming right past it. You know, they're looking at the big dinosaurs and all that other nonsense. But this is beautiful. Mummified cat. And then chemia expanded other chemical processes, dyeing of cloth, glass making, and metals extraction. The chemist could take dirt and turn it into metal. Sorcery. Some things haven't changed. I'm in that tradition, producing metal from dirt. And they're always looking for an overarching theme, you know, to unite the heavens with the simple elements. So the 7 known naked to the eye astronomical bodies were associated with the 7 known chemical elements. And you could even talk in this priestly language. So if you wanted to make a bronze, which is an alloy of tin and copper, you could say, well, let's have the confluence of Jupiter and Venus. It's all there. Mercury, why do we call mercury? Mercury is it's a metal that's liquid at room temperature. It's fast. Mercury is the planet that moves quickest around the sun. Very nice. So this is what we knew 2,400 years ago. We had the 7 metals, carbon and silicon. And the beginning of the shift from practice to theory, or from craft to science, is with the work of Democritus. Democritus lived around 400 BC. Around 400 BC, Democritus, who was Greek, he described the physical world as consisting of a combination of void plus being. Void plus being. These are lofty words. Listen to this. Void, being, not some little equation. It was big ideas. And how did he describe void? Void is something that we would recognize in his language as akin to what we recognize to be vacuum. And being, he said, was comprised of an infinity of atoms. He coined the term atom. Atom comes from the Greek to me, which is to slice. And then if you put a in front of it as an apolitical or amoral, cannot be sliced, indivisible. The atom cannot be sliced. And so these atoms, he attributed these properties. They're indivisible, and eternal. I mean, this takes you all the way to E equals mc squared from 400 BC, and that's all he had to work with. This was brilliant, absolutely brilliant. But to show you that things don't always go in a linear fashion for the better, along comes Aristotle. Aristotle, another Greek, and he decided, no, we don't need all this carbon, sulfur, and so on. He said we will have 4 essences that will describe the earthly world. 4 essences. And here are the 4 essences. Earth, water, air, fire. So those are the Aristotelian essences. And there's actually a 5th essence that describes the heavens. That's why we say something is quintessential. It's heavenly, it's etc. So those are the 4 essences. All right? And then it gets even worse because he has compounds, a combination. So you can take fire plus earth and make dry, earth plus water and make cold, air plus water make wet, air plus fire make hot. This is nuts. And it dominated science for a long, long time. Because we know really earth is an aggregate. It's an aggregate of different minerals, which are compounds. Water, as you know, is a compound H2O. Fire Fire is the product of combustion. It doesn't even belong in this set. And air is a solution. It's a homogeneous mixture of nitrogen, oxygen, argon, rising levels of carbon dioxide, sulfur dioxide, and if you're next to an aluminum smelter, tetrafluoromethane, and so on and so forth. And finally, this thing was knocked down. So we can look at this chart and go back to this one and say, now we can make the connections.